You are moving. Right now. At this exact moment. You are hurtling through space at 67,000 miles per hour, strapped to a rock, orbiting a star, inside a galaxy so vast that if you screamed into it, nothing would ever hear you. But what if you left? What if you pointed yourself outward, past the moon, past Mars, and aimed straight for the ringed giant sitting 746 million miles away? What if you went to Saturn? Here's the thing no one tells you. You could make the journey. You just couldn't come back the same. Imagine you're aboard a vessel. No windows behind you. Only the shrinking pale blue dot of Earth, growing smaller, smaller, until it disappears entirely into the static of stars. For weeks, you drift through what scientists call the interplanetary void, a region of deep space so empty that the human brain genuinely struggles to process it. The silence isn't just absence of sound. It's the absence of everything. Months pass. Then, one morning, something appears on the horizon of your viewport. A pale gold sphere, surrounded by rings so perfect, so impossibly geometric, that the first astronomers to see them through telescopes thought they were hallucinating. You have arrived at Saturn. And that's when the universe stops being beautiful and starts being terrifying. Saturn is not a planet in any way your instincts can prepare you for. It has no surface. Read that again. There is no ground to stand on. Saturn is a gas giant, a churning, crushing sphere of hydrogen and helium so massive it could swallow 760 Earths whole. If you descended into it, you wouldn't land. You would compress. The atmospheric pressure would increase by thousands of times per mile, squeezing your spacecraft like a paper cup under a boot. But here's where the real astronomy facts shatter your expectations. Saturn's gravity, while not as extreme as a black hole, is a masterclass in what gravity does to space and time. Einstein's theory of general relativity tells us that any massive object bends the fabric of space-time around it. The more mass, the deeper the bend. Saturn bends it. And if you orbit too close, inside what's called the Roche limit, tidal forces from that gravity don't just pull you toward the planet. They pull different parts of you at different strengths. Your head, your feet, your spacecraft, all tugged at slightly different rates. Scientists call the extreme version of this process spaghettification. Yes, that is the real scientific term. Your body, stretched like cosmic taffy, pulled apart atom by the mathematics of gravity. But Saturn is only the beginning of this story. Because to understand what's truly waiting in the universe, we need to go deeper. Imagine Saturn's gravity as a gentle slope in space-time. A hill you can climb back up. Now imagine a place where that slope becomes a cliff. And then imagine a cliff with no bottom. That is a black hole. And here's the terrifying truth hiding in the physics of your Saturn journey. The same forces you experience near Saturn, tidal gravity, time distortion, the bending of light, are the same forces a black hole uses, just turned up to infinity. Near a black hole, something called gravitational time dilation occurs. Einstein predicted it. NASA has confirmed it. Time itself slows down near extreme gravity. If you hovered near the event horizon, the point of no return surrounding a black hole, and looked back at Earth, you would watch centuries pass in what felt to you like minutes. Everyone you ever loved. Every human civilization. Every star born and burned, all of it flickering past like frames in a film. While you aged by an afternoon. This isn't science fiction. This is astrophysics. This is the universe explained in the most terrifying way possible. The rules are real. And the rules say, past the event horizon, not even light escapes. Not your signal. Not your ship. Not your scream. Nothing. So what would you actually see? Approaching Saturn, the rings catch the sunlight like fractured crystal. Billions of ice chunks and rock, each one in perfect gravitational orbit, a natural clockwork mechanism 270,000 kilometers wide. But approach a supermassive black hole, the kind sitting at the center of our galaxy, a monster called Sagittarius A*, for million times the mass of our Sun, and the visual experience becomes something no human language was built to describe. The stars ahead of you cluster into a bright ring. Light from behind the black hole bends around it and arrives at your eyes from the front. You see the entire universe wrapped into a halo. Then the darkness at the center, the shadow, grows. Not like night. Not like a shadow you've ever seen. Like an absence. Like a hole cut into reality itself. And as you cross the event horizon, that invisible threshold where escape velocity exceeds the speed of light, something deeply strange happens. You feel nothing. No wall. No alarm. No dramatic shudder. Just crossing. Because the event horizon isn't a physical place. It's a mathematical boundary. A line drawn by the singularity, that infinitely dense point at the center, where physics as we understand it simply stops working. Einstein's equations break down at the singularity. They return the answer. Infinity. And when your equations return infinity, what the universe is telling you is, we don't have the language for what happens here. Here is the paradox that keeps physicists awake at night. From your perspective, crossing the event horizon is unremarkable. But from Earth, if anyone were watching you fall, they would never see you cross. Due to gravitational time dilation, your image would slow. Freeze. Redshift into invisibility. You would appear to hover at the edge of the event horizon for eternity, a ghost burned into the boundary of a black hole, while you experience the complete interior in finite time. Two realities. Both mathematically valid. Both true, simultaneously. The universe doesn't resolve this paradox. It just holds both truths, side by side, in silence. Stephen Hawking spent decades wrestling with what this means for information, for existence itself. His conclusion, still debated today, suggests that information cannot be truly destroyed. That somehow, in ways we cannot yet calculate, what falls in is encoded on the surface of the event horizon like a cosmic fingerprint. You are not gone. You are translated. So what happens if you travel to Saturn? You discover that beauty and destruction speak the same language out here. You discover that the rings of Saturn and the rings of fire around a black hole are made of the same mathematics: gravity, time, mass, and motion, just written at different volumes. You discover that space isn't empty. It is full of rules. Rules that bend time. Rules that stretch matter. Rules that hold entire galaxies together and tear individual atoms apart. Rules that Einstein glimpsed on a chalkboard and NASA now reads in the ripples of spacetime itself. And you discover the most terrifying truth of all. We are not separate from this. Every atom in your body was forged in a dying star. The calcium in your bones. The iron in your blood. All of it, assembled in the heart of a collapsing giant, scattered across deep space, and gathered here, into you. You are not visiting the universe. You are the universe, briefly, improbably, awake enough to look back at itself and feel afraid. If this journey through space and science made you feel something, made the cosmos feel simultaneously closer and more terrifying, then subscribe. Because we're just getting started. The universe has more secrets. And some of them, we are only beginning to dare to ask. The universe is not only stranger than we imagine, it is stranger than we can imagine.